So,
Do you want your mouse? Or do you want me to start skiing?
Well, please hold. Yeah,
I
maybe you
got
can
it.
skip through them.
I'll be your production guy.
Okay.
Hi, world.
Maybe you should just exit the PowerPoint and just let me go through the slides.
Is it this one? Yeah. Just give me a finger when you want to go.
Yeah, let's go. Okay, so a little bit about me. So I work at a company called degree.com. So working to jailbreak the degree. So they are a company that allows you to take courses from Pluralsight, Coursera, MIT OpenCourseWare, anywhere on the web that there's courses or learning. They allow you to create pathways and do that. So that's degree.com. It's my shameless plug there. By trade, I guess, I'm a SQL Server developer and database designer. So I love working with data. I love normalizing it. I love storing it, cleansing it, making it available for people, available through APIs. I do work in .NET, and then I just love Python. And that's why I'm here, because I volunteered like 2 months ago. And so that's why I'm here. I love Python. So I live up in Cache Valley, so some of the Python North people with my wife and 4 kids. Also secretly passionate about remote sensing and geographic information systems. I guess it's just secret because I never really do anything with it. I just like read about it and stuff. So, okay, that's a little bit about me. Okay, so here's kind of the plan. So we're going to first just talk about like an introduction to RethinkDB and getting started, what it is, how it fits in the overall ecosystem of databases and data persistence. Talk about how you can host it, how it can run, some of the clients that are available for it, etc. And then we'll go over some Requa with Python, so that's how we query a RethinkDB database. And then we'll do a full stack RethinkDB with Flask demo. So that's a little bit scary because it's a live demo, but so we'll use Flask as the kind of web server, and then RethinkDB as the database, so we'll be able to access that. And then really where RethinkDB shines is its real-time functionality. So it allows real-time notifications from the database to the web server. And so we'll kind of have, talk a little bit about that, talk about some of the solutions that are out there right now, especially on, kind of the full stack. So there's like Socket.io, there's SignalR on the, in the .NET world, where you can have stuff on the web server to client side. And then we'll do a real-time Requa with Python to show you some of the real-time functionality, and then do full stack RethinkDB with Tornado. So I am new to Tornado, and please don't rip me apart when you see the code, because it's probably horrible, but it works.
Tornado code never looks good, though.
Doesn't it? Okay, well, and it works mostly. So, okay, let's go to the next. All right, so an introduction to RethinkDB, kind of where it sits in the stack. So it's an open source NoSQL database. So it has schemaless JSON going in, schemaless JSON out. They've built their architecture to be distributed, so it's very scalable. It can handle pretty heavy load. It was built from the ground up, is kind of what they say, with a real-time architecture in mind. So there's certain things you can do with even SQL Server to get similar real-time events. You can use something like SQL Server Service Broker, but RethinkDB was actually built from the ground up to be handle a real-time architecture. It also, unlike some NoSQL databases, it allows you to do table joins. So you can actually have, join 2 documents based on an ID. Nothing seriously relational. You wouldn't want to do anything like you do in Postgres or SQL Server. Yeah, the focus is on real-time stuff with everything. So not so much Postgres, a little bit more with MongoDB. Redis is an in-memory real-time database, so that's a little bit different because it doesn't ever get persisted, but so that's kind of where it fits. And if anybody has any anything you want to add, got some shirts or any questions or anything. No? Not yet. Okay. So mainly the reason is if you want real-time database, that's why it was built, is for. So you could use it as, it's similar to Mongo, but Mongo doesn't have like the real-time change notifications that Rethink VP would have.
So you have to be pulling on the front end, whereas Rethink will push.
Correct. Yeah. Yeah. So most common architecture is to pull the database for changes, and then as you get those changes, push them up. Whereas Rethink, you can actually get them live. So yeah, it actually it stores data very similar to Mongo, but it's got that real-time functionality. Yes, sir.
Could you go through maybe things that it's not great at?
I will on a slide later that has a big stop sign on it.
Awesome. Okay, thanks.
Okay. Yeah. So. Okay. So getting started, and this is getting started as far as installing it and actually starting to use it. So Rethink DB, the server side where you're actually running the database, is officially supported on Ubuntu, OS X, CentOS, and Debian. Windows is out of luck, which is a developer. I'm sad about that. Rethink DB is the client, so they officially support clients for JavaScript, Ruby, and Python 2 and 3. I actually heard they had a really good Utah.js Rethink DB meeting not too long ago. So
yeah, they were in Utah.js. That's actually why you had that box, so we can see it.
oh, perfect.
I just said it's happening, and they were like, "Okay, bring us in on the box."
Well, thank you.
Yeah.
So they were actually there. They had reps there.
Yeah, it's Brian Paul, and Mike Lukowski were there.
Cool. Yeah, and if it says anything about the company, like the fact that they did that, like she just reached out to me and was like, "Hey, we're gonna send you this," and I was like, "Awesome."
They were super excited too. Like,
Yeah.
the moment I told them that.
Yeah, they're very passionate. I was actually introduced to it at Open West back in May and got really excited about it. So Rethink DB 2.0 drivers, which it was just released, I think a couple months ago, not too long ago, they actually have native support for the Tornado web server, which is why I decided to go ahead and try to show an example of that. Because the Tornado web server is built to be asynchronous. It's kind of in that realm of using real-time data, so I guess that's why they decided to do that. Yeah, there are other community-supported builds for the client, so there is a .NET client that you can use, but they are community-supported. They're not officially supported by Rethink VP. So kind of the stack we're going to look at today is I host it on a Ubuntu box, Python obviously, and then I'll show it with both Tornado and with Flask. With Flask, we will not use the real-time functionality, just because that web, we'll get the real-time from the database to the web server, but not out to the client. So, any questions?
What kind of tools are available for it? Kind of something similar to PGM and basically
So they actually have a built-in administrative GUI, which is amazingly powerful and simple and nice to use. So yeah, and I'll show you that when we get into it. All right, next. There you go, Zach. Here's your stop. What isn't Rethink DB? So it would obviously not fit all the needs, right? Because you have that whole polyglot persistence thing where there's different ways to store data. So if you need full asset support, if you're building heavy relational models, your relational database is going to be better. While they do support asset transactions to a single document level, you can't have it for if you're saving multiple documents. Yeah, so RDBMS, relational databases are going to be better suited for relational models. Deep data analytics and number crunching are better left to some of the big data players, I guess, like Hadoop. This, a lot of this is actually right from Rethink VP. They do a very good job on their site of explaining what they're good at. So, yeah, and then search, that's still going to be better with something like Elasticsearch or Lucene solar type solution. Does that answer your question?
Yes, thank you.
Okay. Any other questions?
Does it do
Oh, you get a shirt. So that's your
that's okay. But does it do any basic aggregation or basic?
yeah, so you can do some aggregate methods on it. Yeah.
Oh, okay. Okay.
Okay. Next. Okay, so Requa is the query language for RethinkDB. And the three principles that they have for their three supported clients, Ruby, JavaScript, and Python, are it is embedded in the client language, it's chainable, so you can do chainable calls, and the code actually executes on the server, so that's more important than trying to execute the code on the client, perform the full query and send it to the server, so it actually is executed on the server. Here's some sample Requa. So right here we have a table create statement, we have an insert statement, so you can see it looks very, very natural in the Python language. You can get a cursor back from the table and iterate through that. You can apply filters. So right here, you just do .filter and pass your condition, your expression into the filter, and you'll get it back. So yeah, that's kind of what it looks like in Python. Okay, let's go on. Okay, so Rethink VP with Flask. Demo web app using Rethink VP and Flask. All right, so let's try this out. However you want to do this.
If you move it to the other screen, it'll show on the Hangout.
Okay, cool.
So I think the screen is set up to your right.
Is it going to be that skippy?
It's skippy because that's not your mouse. There's your mouse.
Oh, okay.
You're seeing past tense. Yeah, see, you went all the way to the right again.
Oh, you skipped to my. All right. Oh well.
Okay, where is it?
Let's go to the Rethink VP Flask.
This one, right?
Yeah.
Click it. And then move that to the right. There you go.
Okay. Cool. And then maybe I guess I'll try to do it like this.
Sublime, right? Or no.
PyCharm.
Control plus if you want to move the text. Control shift plus. Okay, well,
Yeah, I'll do it. I can do it with this. Okay, can everybody see that? Is that big enough for everybody? Okay. So, all right, how do I can't see this. It's behind the this screen here.
Sit down.
Yeah, there we go. Let me try that.
You could set it on top of this.
Perfect. Thank you.
Use your phone there.
Yeah. Okay. So, so this is a Flask app right here. So you can see it's, got the regular kind of Flask template over here. It's pretty, it's very simple. So we have one HTML page, one CSS page, and then just our main cheese.py. So what I've kind of chosen to focus on as far as like my data set is cheese. So we're gonna have a cheese database. And I better make sure I'm following my notes here. Okay, so the first thing we're gonna do, actually I'm gonna go ahead and, so this is the Ubuntu server that I'm connected to. And this is open, so once we start actually creating a database, you guys are more than welcome to share in and try to hack it. Go ahead. Okay, so this is the administrative GUI that I was talking about. Nope, I have to go start it first. So typically, if you run it, it will just bind to localhost. But if you do this bind all, it will bind to all listening ports. So now anybody can hit this on port 8080. So if you browse out to thepearts.com on port 8080, you should see this. Please don't mess anything up. So yeah, this is the administrative UI. So they kind of have a dashboard where you can see your cluster performance. They're very focused on making their architecture scalable. So you can easily go in and add new shards, for example. So you come in here, you can easily go in and manage your shards from this interface. I'm going to actually go and create a database named Cheese Flask. And then, okay, and then what I'm going to do is I'll go ahead and create a table using some Requa, so we can kind of see that in action. Okay, so right here, I'm going to import RethinkDB as ours, so you can just install this with pip. I'm going to go ahead and connect. So by default, you know, if you just called connect with no parameters, it'd be localhost 28015 and the test database. But we're going to connect to the database that we just created on that port, and then we're going to create a table named cheese. So I'm going to kind of try to do this so that we can see it show up in here. Let me actually just like, let me just run it in idle. Is that appropriate?
The funeral.
Is it? See, I never know these things. Okay, so I will show over here, and then I'll try to like show this over on the side. I'm going to import RethinkDB as R, connect, and then create the table. Nope, I'll just type it out. Okay, so now we have our module RethinkDB, connection equals r.connect.
What's the default? You don't need to write it.
Yeah. Thanks. We'll make it go faster. But I do, I think, have to connect to db equals cheese flask. Oh, we should see this connect. Over here, we should see that be created. Oh no, we have to create the table first. Okay, so now we'll do r.table create, and we'll name it cheese. Run, and then we'll pass the connection into the run statement. And you can see that you get a return on the type of tables, and the cheese table is created. Thank you for the applause. Okay.
He just wants a shirt.
Okay, so now if we go back to the Flask app, we now have our cheese Flask database. And kind of the, I guess the suggested pattern is to, before the request, create the connection to the database and connect. And then you have a teardown request, which will close that connection. So we have the app for request and the app teardown request. And then we have a get all. So this is just going to access it at cheese and get all of those cheese items in a RESTful manner. So we're actually just going to call r.tablecheese.run and then pass in this connection that we established up here on the before request. And then we'll just dump that out to the screen as JSON. We also have a get by ID, so you can access a specific cheese if you want, which just passes in the cheese ID. So in Requa, the format for that is you do a .get and then pass in the ID of the object you want to return. So very similar to like MongoDB. We'll also set up a default route, which will just have this cheese.html template, and then it will set a list, which is all cheese. And we will just very plainly loop through that list and print out all the cheese items, put it in this div. Okay, so we should be ready to test this out. Let's go ahead and run it. And boom. Okay, so we have no cheese items. So let's go ahead and add some cheese in there. So I want insert cheese Flask. And I'll actually just see, that's my only public presentation. Probably my last, too. Okay, so I'm going to run this insert cheese flask.py, which is right here. So it's going to connect to the database, connect to the cheese flask database. Just going to insert some American cheese. It has a status of moved. I was going to do a play on like who moved my cheese and try to make a game out of this, but that didn't end up happening this time. We'll also insert some pepper jack, and then we will run that. So if I do this, and notice the lack of real-time updating on the Flask site. So this repo right here isn't actually using the change feed notifications, so I'll show you that later. So for now, just think of this as a regular NoSQL database. This is going to insert those records, but it's not going to try to push them anywhere. So, okay, so if I do insert cheese Flask, and if I come over here and refresh, boom.
Yay!
Yay, so now we're getting the cheese back. But you can see it wasn't real time, right? But this is still useful. You could use this as a distributed, scalable database. So,
Question.
Yeah.
Was the ID set by?
Yes, so you can manually set the ID in your insert. So if I go back to this, so right here, because I did not pass in the ID, it will automatically generate a GUID for you. If you pass in an ID, it will use the one that you pass in. So yeah, good question. Any other questions?
Ask me what was the generation strategy for the ID?
To you.
It's just a GUID. So right here, yeah, it's just a unique ID, a GUID that gets generated on their side.
Is there a constraint for that, like asking me?
Yes, that will be unique on the database side. Yeah.
But you can pass in anything. It doesn't have to be a UID.
Yeah, so if I change this, if I add in ID and 1, and then put in some like Swiss. Mama? Oh, thank you.
After ID 1, ID.
Oh, thank you.
This kind of hard coding.
It's open.
No!
It's open source.
That's the way I like it. So if I run this one, and then I go and look at here and refresh, you'll see that that one is, yeah, so if you pass in ID, it will use the one you pass in. Otherwise, it will generate this ugly looking GUID that is horrible to cluster indexes on. So.
And because Mongo has some restrictions on its IDs, right?
I'm not sure. Like what you can pass in as the ID?
Yeah.
Yeah, I'm not too sure on that.
How's it internally? I mean, that's, yeah, we've got that one. And then, but the UID is treating it as a string. It doesn't, it's not apply.
Yeah, so I think it's pretty lenient. So they should be unique. So if I try to run this one again, I would expect that to fill. But let's see what it did. Yeah, so it did fail. I just didn't catch the
Silent,
error.
yeah.
Yeah. So the ID you use does have to be unique. I'm not sure what the constraints are on.
If you
Like
run
types
that
and stuff.
again with a different flavor, will it update it?
No, you'd have to run it with an update statement.
Oh.
Yeah. And yeah, if we look at our Flask app, oh, I did have an update, but I decided that it would be too long, so I didn't do it.
Question on this, it's committing to the real database, I wasn't clear what you were saying, or it's committing real time or not?
Yeah, it's committing real time. It's just not trying to distribute those changes elsewhere. So,
Right, gotcha.
so if we go back to our Rethink DB administrative thing, you can actually run things from here. So this was already saved in there, but they have a data explorer as well, so you can go and see the items in there. So it's actually in the database right now. Yeah, and I'll kind of get into the real-time aspect of it in a minute. So, okay, so that's the demo with Flask, which is cool in and of itself because I love Flask. It's really lightweight, and for building an API on something like a Raspberry Pi, I love using Flask. So. Okay, so kind of a real-time interlude. There's a guy with his sheep that they bred, and their wool won't stop growing. I don't know if you guys have heard about this, because they're bred to grow wool. And so if they ever get lost in the wilderness, they'll end up growing so much wool that they'll just die. So, but they look really awesome.
This is Shrek. He was lost in the wilderness of New Zealand for over 4 years.
Yes.
His locks were about this long. They were huge.
I think that's pretty cool. Well, it's sad that they get lost, I guess. But. Okay, so we've seen that RethinkDB can be used as a good NoSQL database solution, right? So if you just want to use it in something like Flask, you don't need any real time. On the web, it's a really good database to use. You might compare it to something like MongoDB in that case. We get the awesome GUI that they offer, amazingly clean Python client code, so it's very straightforward to do database operations, and then you get the scalability that they offer with their platform. But what we really want are the real-time features, right? That's why it is such an amazing database. So group discussion. So I just was curious kind of what kind of real-time solutions you guys have used. So I've seen cases where we've used message broker on to get messages from the database to the web server, and then we'd use something like SignalR to distribute that out to each of the web clients. I was just curious if anybody was doing real-time data or had solutions. What's it called?
Stop. Yes. Something.
Cool. Sales.js.
Oh, on the back, Django is actually releasing something called Channels through Andrew Godwin, and they'll be doing real time very soon. Yeah. Cool. So the same guy who did South.
Okay, so I think it's where we're at in technology. I think it makes sense that we want real-time data. We don't want to be waiting for data. I think so. Some of the things that make it so difficult are connections based over HTTP. So HTTP was really developed to be kind of a request-response approach. So you make a request and you get a response. And if you want to get continual requests, if you want to get a stream of data, that doesn't really work so well. So there is a solution in HTTP called long polling, where you can make a connection to the web server, and then you just basically keep that connection open until you get a response. And then once you get the response, you immediately close the connection and reopen another one. So that's called long polling. And a lot of the frameworks out there like SignalR they'll use long polling on occasion if there's not other methods available. And some other challenges I guess with using with HTTP is you have HTTP caching, which doesn't really apply to streaming data. So yeah, that's some of the challenges with real-time data where we're so based around HTTP. So a solution is WebSockets. So WebSockets uses HTTP to establish a connection to a database or to the web server, And then it then transfers that to a TCP connection on a different port, and it will just keep that TCP connection open and keep that run data between there. So a plethora of libraries support long polling. They support failback to long polling. So they'll if a browser doesn't support WebSockets, or if you have a proxy in the way or something, they'll fail back to using long polling. But as you can see, like most browsers now, actually support WebSockets. So, okay, so that's kind of on the web server to client side. And then RethinkDB is going to satisfy the database side. So we don't have to rely on a message server or a message queue like RabbitMQ or something like that. We can get real-time updates from the database. Yes?
Does RethinkDB have fallbacks in place for older browsers, or is it focused for WebSocket?
So typically, RethinkDB wouldn't be streaming directly to a browser. It'd be streaming to the web server, and then you have to rely on some other framework to stream from the web server out to the browser.
Yeah, that makes sense.
So yeah, it doesn't. Yeah, it doesn't have to do
Yeah, they
that.
don't support that now. They did mention that there was a solution for that. That E5JS did not quite work.
That what?
They're working on a solution to go straight from RethinkDB to
Oh.
They didn't really describe it.
So when they do it with JS, do you do like Node.js on the server side, or?
Well, they don't have anything yet. Like, they actually didn't describe it. They just said they're working on it.
Oh, okay, cool.
So it's an open question. Maybe the product has something.
Cool. So yeah, so it can be done with other databases. Like I've actually used SQL Server Service Broker. You can use a .NET client and maintain and get live updates from SQL Server. It does have quite a few limitations on like queries you can run. It has to be a single table, a single column. You can't use aggregates. So some of the queries that SQL Server enables to run are pretty limited, whereas RethinkDB, they're more flexible. And it was built from the ground up to handle that real-time streaming. So. Okay, so this is RethinkDB change feeds. It's what it's called. This is how you monitor a table for changes. So in Python, what it's going to do is it's going to open a cursor that will just stay open, and you can continue to iterate on it. So filters can be applied. So you can put a filter on the change feed. So you can say, I'm only interested in cheeses that have a status of moved, right? And then because you want to know when your cheese moves, right? So you have to watch that. Okay, so RethinkDB with Tornado. So before we kind of get into that, we'll just go over watching real-time data from so we can actually see the data coming to the server. Let me look at my notes here and make sure I'm getting everything. Okay, so I'm going to go create another database in here called cheese real-time. Okay. And then I'm going to, so this is changefeeds.py right here. So this is the syntax for the change feed. So that is the keyword right there. Is you write your your Requa right there. So you could have filters, whatever you wanted, and then you do .changes, .run, and then you pass in the connection. And so what that's going to do is it's just going to open up this cursor and leave it open for any new changes coming from the database. So this will just open up a permanent call to the database.
So does it have a sleep in that for?
No, it will just leave it open. Yeah, it just leaves that cursor
I'm
open.
just wondering, so like I have 5 items to start with. And that for loop runs, and it goes through 1, 2, 3, 5. Then what happens? Does it?
It's probably a generator.
It leaves it
Well,
open.
yeah. So it leaves it open. Does it just keep like? Then it waits.
It just keeps on. It waits until you kill it.
Okay. So it will make an infinite loop essentially.
Yeah.
Well,
Okay.
no, because it only runs as many times as that event happens, right?
Well, but then if a new thing comes in,
Yeah, so
Real-time thing for subscribers for feeds, it's gonna keep going. Actually, no, there was a point where it closes, right?
I'm not sure. There may be like a timeout where it will close. But here, so this is what it looks like if I run this. So this one, it's going to connect, create a table, and then insert some records, just 2 records. And then it's going to immediately start watching for more records. So if I run this one, insert, no, change feeds. So you can see it's just waiting there for new records to come in. So I'll kind of set this over here. And if I go to that database, if I just go to the Data Explorer, you can see those 2 records were added. Okay, and then if I want to add another one, so I'll come over here and open up another. Command prompt. Okay, so pi. So I'm going to insert some records into the cheese real-time database, which if we look at that right here, it's just going to connect and insert two new cheeses. But you will notice that since I'm watching for that right when I run it, they show up over here.
so it isn't.
Yeah, it's an infinite loop. There may be a timeout. I've always just had to kill it when I'm doing it like this. So yeah, so I can continue to do that, and that will just continue to monitor for those changes. So that's showing it pushing data from the database up to the server, right? So now, that's useful, but really we want to show this in a web server, in a browser, right? So that's where Tornado comes in. Okay, so let's just go read about Tornado a bit. Okay, so Tornado is a Python web framework and asynchronous network library originally developed at FriendFeed. By using non-blocking network I/O, Tornado can scale to tens of thousands of open connections, making it ideal for long polling WebSockets. So you can see it's right in line with real-time architecture. And that's why I believe RethinkDB wrote a native driver for Tornado. So if you, let me open up the Tornado project here. Okay, so we're going to import the Tornado stuff. I actually surprisingly got this to work on 3.4. I thought that, like all the demos I saw, or all the the guides I was reading and stuff had it in 2.7, but got it working on 3.4. I had to do something really weird and hacky because it was running on Windows, and something with Windows not closing socket connections. So there's, if you run into issues, I'll try to like post that on here. Over here. Did we stop presenting? Yeah, that's okay. Oh. Okay, so here is Tornado. So we're going to import RethinkDB. We have the Jinja templating framework library. We're going to set up our template environment. And then here is where, this is new to 2.0. So just recently, you can set the loop type on your RethinkDB instance to Tornado. And I'm not quite sure exactly what this does on the back end, but it makes it so that it sets up kind of the callbacks for you. It sets up the the connection so you're not going to run into issues. I'm not sure exactly what they did on the back end, but you need to set the loop type to tornado. Just know that. I'm going to configure the host and the port and the database cheese tornado, which I actually need to go create. I will just come here. I love how all the names turned out. They just roll off the tongue with cheese at the beginning. Cheese tornado, cheese flask, cheese real time. It's nice. I'm also going to create a cheese table so that I don't have to have the setup in Tornado. So, you'd probably want to have a setup function in here where if the database and table didn't exist, you would go ahead and set that up. And for the demo's sake, I'm just going to go ahead and create that database so we know it exists and create the cheese table.
You're going to need to change line 41 then, because you just named it cheese table.
Oh, I did. Let me go change that. Oh well. There it is. Okay. Thanks for catching that. Okay. So this uses yield statements and the coroutine in Tornado, which I'm not too familiar with asynchronous libraries and stuff in Python. If anybody wants to elaborate, please feel free to do so.
Yeah.
Okay, then we'll just skip it. So this is going to make it so that we are asynchronously now going to be getting data from RethinkDB to the web server, and then we are going to push that code streaming to the browser. So any client that connected would get this data in real time. So feel free to do so. So if you, well, actually, yeah, maybe we won't be able to connect to this one. But feel free to go and add data into, so just go to thepearts.com on port 8080. And go to the Data Explorer. And if you follow their very useful hints, you can go ahead and insert some data. So go ahead and do that. So they have this, this GUI is impressive in and of itself, like the suggestions you get. So go ahead and feel free to add some stuff, and you can see it show up on here. As I'm going to run this.
Instead of cheese real time.
Oh, I see. On the when you're doing the Data Explorer. Oh, thank you. Yeah, cheese tornado. So change that to cheese tornado if you guys want to try some inserts when I run this, and you'll see them real time. Okay, so we have the home handler. So here we're going to get the cheese collection. So this is just going to use the standard Requa. So it's going to look at the cheese table, but it's going to do it as an enumerable with yield. And then thanks to Zach, this is actually going to work because the front end, I'm not so good at, especially the JavaScript in here. He helped me out with that. I also got, so this is kind of based on a presentation that someone else at RethinkDB did. So I will not take credit for the majority of this code here. So we're going to show the cheese. We set up socket handlers. I do not know much about Tornado though. But let's, does it? Well, the Django tells me when it doesn't follow PEP, so it's nice. Yeah. Okay, so I'm going to run this, and if we are lucky, let's see what we get on localhost 8000. Okay, so there we go. So somebody added something, and go ahead and let's try adding something else. So here is the bug that we could not figure out. When you add something, you just get a white square. So let's show how that works. Let me kill this change feed watcher. And just to show that we're getting the live updates from the database to the server, I will go ahead and kick off watch cheese tornado. So this is just opening up that cursor again so that we can watch that. So we can kind of see it coming in here, which is much less interesting than the white squares that show up. Okay, and then let's go ahead and open up another one. Okay. Oh, I hate how Windows 10 does that. Keep on adding data. Let's see if we can kill it. Okay, so I'm now going to run insert cheese tornado, which is just like the others, except for it's going to insert into cheese tornado. So pi-3.4 insert cheese tornado, and you can see that I am adding squares faster than you guys. So you can see it coming in here into the server, and you can see it coming in here. So yeah, the JavaScript, we couldn't figure out why we weren't getting actual data, and we were just getting squares, but that's it. So now we're getting live data from the database, regardless of where the updates come from, to our Tornado web server, and then out to the client. Yeah. And yeah, very many thanks to these sites. They have some great information on both setting up a Tornado, on kind of the challenges of the real-time database or the real-time architecture, and thanks to Zach for helping the front end. And that's it. So thank you.